Let us get started with Lean Six Sigma Green Belt training, which is driven using a statistical tool called Minitab. Minitab is a graphical user interface tool, which is pretty easy to get started with statistics. All right. Here are the course objectives. A quick introduction about course objectives. And also this particular topic is all about the introduction to Lean Six Sigma. So you learn about what is Lean Six Sigma, how did Six Sigma evolve, and what is the history of Six Sigma. You will be learning about the various types of Six Sigma methodologies. We'll be looking into basics of the statistics, what are the various data types, etc. And then we'll be looking into a case study of internet service provider to understand the basic descriptive statistics. We'll be looking into few of the graphical tools such as box plot, histogram, etc. We'll be looking into the probability distribution, including the normal distribution. We'll also try to understand the various variants of sigma. You have various variants of sigma. We'll try to understand those. And then we are going to recap the entire session in a nutshell. All right, let us look into the preliminaries of Lean Six Sigma. What is Lean Six Sigma? Most people keep asking me this question. What is the difference between Lean and Six Sigma? Yes, these two are different methodologies, no doubt about that. Lean is all about reducing waste in the process, removing the waste. It deals with waste with a strict stick. And Six Sigma is all about reducing the variation. Lean is all about reducing the waste. When these two shake hands, the effect that you're going to bring into the improvement initiatives would be extremely robust. Lean and Six Sigma nowadays is not seen in isolation. Lean concepts plus Six Sigma concepts together are going to give you profound results. Hence, it is called as Lean Six Sigma nowadays. You no longer differentiate between these two. Who are the target audience and what industry is it applicable in? Any person, right from the junior resource to the board members, CEO of a company, CXOs, everyone is expected to undergo this training or is eligible to undergo this training. What industry is it applicable in? Oh my God. I cannot tell you at this point of time how many industries it is applicable to, because otherwise I would be taking the next 1 hour just discussing about the industries. That goes to say that it is applicable to each and every industry. Financial services and insurance. Within that banking domain, insurance domain. It's applicable in life sciences healthcare industry. It is applicable in energy and resources. Oil and gas within that. It is applicable to pharmaceutical industry. It is applicable to marketing industry. It is applicable to manufacturing industries. It is applicable to consumer and industrial product industries. Any industry, by the way. But let me tell you one interesting thing. It is also applicable in a crazy industry called as cow milking. Have you ever thought that we can implement Six Sigma concepts to cow milking? Oh yes. And by the way, let me tell you one more interesting stuff. Israeli cows produce maximum liters of milk per annum on an average. This goes to say that Israel is implementing Six Sigma concepts in its fullest meaning. Oh yes. It can be used in sports industry as well. You can just type Roger Federer plus Six Sigma. Roger Federer, by the way, is a tennis superstar. And you'll be astonished to see that he is implementing Six Sigma in his practice. Amazing. It is used in boxing. It is used in various other interesting industries. It is used in Formula One race, by the way. Right? Let me ask you this question. I'm pretty sure you all are aware of Formula One race. In Formula One race, there is something called a pit stop. What happens in a pit stop? Driver, after going around the circuits for few circuits, would like to fill fuel. He would like to replace the tires. He would like to check his brakes and then get started once again. How much time would it take to replace 4 tires, fill the fuel, check the brakes, and let the driver go? You'll be surprised if I say that it is less than 2 seconds. How could they achieve this impossible task? Right? For a few of us, it might be sounding that, oh my God, this is impossible. How can you change 4 tires, fill the fuel, check the brakes, and let the driver go in less than 2 seconds? It happened. Mark Webber, Red Bull, right? That team achieved this impossible task. I would not say impossible, I would say rather extremely difficult task. Yeah. How old are Six Sigma tools and techniques? To answer this, let me tell you one simple thing. If you go to Subway, and when you order a sub, you might have noticed that on the table on which they chop the vegetables, there's a small opening. And all the waste particles of the vegetables are simply pushed into this. And there is a waste container which collects the waste. Just a simple push. Otherwise, what would happen? You would place your dustbin somewhere here. You would pick up all the waste. You would take that waste and put it here. On the way, you would drop few of the waste and then you'll bend, pick it up again and drop it once again. So it's a waste of time, right? Instead, you chop the vegetables and just push it here. This concept is called as clean to clean, right? And this concept was introduced by Japanese housewives way back in, I believe it is in 16th century or so. So that is how old Six Sigma tools and techniques are. And most of the scientists have worked in developing Six Sigma tools and techniques, or rather they developed tools and techniques which are now used in Six Sigma. All right. What are the various Six Sigma methodologies? We'll be discussing in a short while about 2 different methodologies. And Six Sigma Green Belt primarily deals with DMAIC. Define, measure, analyze, improve, and control. Just give me 2 minutes while we get into this. And there is another Six Sigma methodology called as define or design for Six Sigma, in which there is DMADV. DMADV, what does that stand for? Define, measure, analyze, design, and verify. We'll do a deep dive into these 2 methodologies, but primarily a Six Sigma Green Belt would be driven on DMAIC. All right, let us look into Six Sigma Maturity Continuum. What does this mean? Six Sigma is all of these 4. It is a metric, it is a methodology, it is a management system, and it is philosophy of a life. Sigma, by the way, is a Greek letter which measures variability of data. And as I've already discussed, Six Sigma means reducing defects and reducing the variation in the process. Let me explain this quickly about reducing the variation or variability. I'm pretty sure most of the people know the game cricket. C-R-I-C-K-E-T, cricket. Right? It's heavily played in India. All right. If any of y'all are already aware of cricket and the cricket ball, then let me ask you this question. What is the circumference of ICC cricket ball? International Cricket Council cricket ball. What is the circumference of that in mm? Right? Do not worry. I'll let you know on that. Lower specification limit is 224 mm. Don't worry about these specification limits and all that. We'll do a deep dive in the control phase as well. And upper specification limit is 229 mm. Right? So any ICC cricket ball that is manufactured should be within these limits. Assuming that this is the mean, let us say these are the cricket balls that are manufactured. Say circumference of the first cricket ball manufactured is 228 mm. Second cricket ball circumference is 225 mm. The third cricket ball circumference is say 229 mm exactly. Fourth one is 224 once again, and fifth one is 226 or so on and so forth. If you see here, the variation is high in the process. Can you guarantee me that the next time the cricket ball that I'm manufacturing would not fall outside these limits, lower and upper specification limits? Can you guarantee me with confidence? Maybe, may not be. But let us take another example of actually explaining the variation. Let me write this down. USL, LSL, ICC cricket ball circumference is 229 mm, and then LSL is 224 mm. Now let us look into the cricket balls. It's first cricket ball circumference, which is manufactured, say it's 226. Then it's 225.5. Third one is here, fourth is here, fifth, sixth, seventh, eighth, so on and so forth. The variation is very less. Now can you tell me with a higher confidence in comparison to the previous example that the next cricket ball that is going to be manufactured would fall within the specification limits? I would agree that you would say that here in this process, I would say that the next cricket ball that's going to be manufactured will most likely fall within the specification limits. I would say this with greater confidence. But in the previous example where the variation was high, you would say that with less confidence, there is a possibility that the circumference of the next cricket ball manufactured would fall within the limits. So look at the importance. Tomorrow, if you want to speak with your client and say, what is the level of confidence that you'll be able to complete your project on time with good quality? If you were to do that, you will have to ensure that the variability is reduced, and which to some extent also helps you reduce the defects. All right. What is Six Sigma? It is a metric. Definition of Six Sigma in most cases is this: 3.4 defects per million opportunities. Think about this in this way. Suppose I'm manufacturing a mobile phone. What are the various components that would actually complete my mobile phone? I need to have a screen. I need to have camera. I need to have the keypad. I need to have the battery. I need to have the motherboard within that. I need to have the chipset, so on and so forth. Each component of this particular mobile phone is called as an opportunity. So if within a mobile phone, in order to manufacture and assemble a mobile phone, suppose there are 10 components, then each mobile phone has 10 opportunities. If I have 100,000 such mobile phones, and if each mobile phone has 10 opportunities or 10 components or 10 features, 10 parts which I have to assemble, right? Then the total count would be 1 million. Out of these 1 million opportunities, there should be not more than 3.4 defects. That is when it is called as following a Six Sigma process. It's extremely difficult to achieve such high levels. All right. Let me tell you this. Very interesting. Pay attention. A process which operates at 3 sigma level. Yeah. And suppose this is electricity generation company, right? And if it is operating at 3 sigma level, you would not have electricity for 7 hours per month. If the same electricity generating company operates at 6 sigma level, then you would not have electricity only for 1 hour in 34 years. Astounding, amazing. Look at the difference. From 3 sigma to 6 sigma, there is a significant improvement which no one can expect. If a power generation company is operating at 3 sigma, you would not have electricity for 7 hours per month. If the same company is going to operate at 6 sigma, there won't be electricity for 1 hour every 34 years. Oh my God, amazing. Do this for cow milking example which I've given earlier. Israeli cow on an average produces 10,000 liters of milk per annum. In US and UK, it is approximately 6,000 liters each cow can produce per annum, liters of milk. In India, it is 3 to 4,000. Think about that. What is the kind of difference that you can bring into your organization, to your firm? All of a sudden, you'll become extremely relevant in the industry. All of a sudden, your profits are going to increase like crazy. And this is the kind of breakthrough methodology Six Sigma is. Yes, Six Sigma is a methodology as well. It is DMAIC. Primarily, we'll be going to discuss about DMAIC in Greenbelt. And then there is a design for Six Sigma as well, which we'll discuss shortly. It is a management system, a way of life. It is a philosophy. All right. Here is a DMAIC. D stands for define, M stands for measure, A stands for analyze, I for improve, and C for control. It is a structured and repeated process improvement methodology which you do again and again, right? You need to keep improving your standards. So you keep doing this. This is a repeated process. It is a structured process. You follow this in sequence. Define, measure, analyze, improve, and control in that sequence. It focuses on defects reduction. So whenever you have a defect, you identify it and try to fix that. So it's kind of reactive process, by the way. Methodology. It's a reactive methodology. DMAIC primarily focuses on improving existing products and processes. Let us look into DMADV on the other hand. DMADV is part of design for Six Sigma. And DMADV is not the only methodology within design for Six Sigma, but this is the best known methodology by far. You have various other methodologies such as IDOV, which is also designed for Six Sigma concept, right? Identify, design, optimize, and then validate, in short. But design for Six Sigma, DFSS, arose through the new product development plans of companies such as General Electric, as well as NASA and the US Department of Defense, right? Look at where design for Six Sigma and Six Sigma methodologies are being implemented. All right, let us understand DMADV in brief. Define, measure, analyze, design, and verify. This is the abbreviation of DMADV. Its strict focus is on design. It completely focuses on design of the products to ensure that it meets and exceeds the customer expectations. It focuses primarily on defect prevention. It will not let the defect happen. It helps develop new products, new process, or it will also help you re-engineer existing products or process. Even before we proceed further, let me ask you this question about DMADV primarily. Have you undergone 1 day of USB foundation training and 2 days of practitioner training? All the IT folks, all the software folks, all the folks who are comfortable in using laptops. I am sure you understand what USB means, right? But do you know that there is a training for 1 day foundation and 2 days practitioner? Very important, extremely important training. Yeah, I'm sure you might not even have heard about such a training. The reason is extremely simple. Such trainings do not exist. Such trainings do not exist. Why do you need a training to place a USB device in the USB drive? Try putting your USB device into any other slots, into your LAN slot, VGA slot, power slot, or some other slot. Can you do that? No. A USB device only fits into a USB port. That is called as design for Six Sigma. If you heat your iron box in order to iron your clothes, if you heat your iron box, does it get heated beyond a temperature? No. It stops automatically if it reaches a particular temperature. That is called as design for Six Sigma. It is not letting the damage exceed a certain limit. Design for Six Sigma. Isn't that amazing? Yeah, that is what design for Six Sigma, or well-known design for Six Sigma methodology, DMADV, is all about. All right, now let us look into Six Sigma management system. Six Sigma helps organizations with the following. It, in the first place, helps to improve your process, or if you have a bunch of processes, you can improve all of those. And most importantly, you can align with the strategic objectives of the organization. Yeah, most people face problems over there. Six Sigma also helps teams to focus on those projects which will give you high impact on the business goals, which will increase your brand image, which will increase the quality of the products, right? Which will reduce the number of defects, which is going to impact your bottom line and top line. So you'll be able to focus on those kind of projects. Six Sigma ensures that organizations achieve faster, improved business results. Yeah, you'll be able to achieve results in a much faster way, and the results which are extremely improved, right, in comparison to any other improvement initiative that you undertake. Six Sigma establishes mechanism not just to achieve improvements, but to ensure that your improvements are sustained in the long run. And that is what Six Sigma is. That is why it's extremely important. It's extremely imperative just because it will help you sustain the results in the long run. All right, let us look into where Six Sigma focuses a lot. Six Sigma focuses a lot on reducing the defects, improving your yield significantly, increasing your net income, and continual improvement. That's the most important part. It will help you reduce the number of defects in your products. It will help you reduce the bugs in the software applications. It will help you increase the number of products manufactured each hour. It will help you increase the loans which are processed against the loan applications which are received. It basically improves the productivity of your employees as well by improving your processes. Higher net income. If you have a new shopping mall, it will help you improve the occupancy percentage. It will help you increase the number of footfalls. If you are having an inventory of raw material, it will help you reduce the inventory cost. And for most of the logistics company, reducing the inventory cost even by 1% means millions of dollars. So these are few of the areas where Six Sigma has its focus on. Yeah, and one more important thing is when it comes to measurement, people also measure color. When you want to improve something, you can also improve the color. And color is measured in cooking as well. I'm sure most of you all are aware of McDonald's. Yeah, the Burger King, right? McDonald's. Feeling hungry? Yeah. McDonald's says this: we don't cook, we don't bake, we manufacture. Try eating burger in any of the McDonald's store, it will taste like, the color will be exactly the same. How can they achieve this? They can achieve this by measuring a small component of your cooking, which is color. So they are giving utmost importance even to color of your burger that you're eating, right? There are a lot of color models. If you want, you can just explore CYMK. You have RGB color models, red, green, blue, etc. You can just explore out of context. Just look into that. All right. Six Sigma also focuses on reducing non-essential, non-value added activities in a process. We'll discuss about this in detail in value stream mapping, which is, by the way, a lean concept, which finds its roots deep into Six Sigma nowadays. All right, let us look into history and evolution of Six Sigma a little. Scientists who contributed to Six Sigma significantly, right? Normal curve. This is the most beautiful curve that you can see. It looks like this, very symmetrical, right? Very beautiful. Normal curve. Carl Friedrich Gauss has come up with normal curve. It's also called as Gaussian curve, by the way. Control charts were a result of Walter Schwartz in 1920. Design of experiments were a result of Ronald Fisher in 1935. Box plot, which we'll be discussing in this particular session itself, was an output or outcome of John Tukey's work in 1977. And let me ask you this question: who has the world's largest Six Sigma team? Answer is given here. It's US Armed Forces. US Army has the world's largest Six Sigma team. And they have come up with FMEA, failure modes and effects analysis, in the year 1940. AIAG, Automotive Industry Action Group, has come up with measurement system analysis. In the measure phase, we'll be looking into attribute agreement analysis for Greenbelt. Though we have gauge R&R also, but in Greenbelt, we'll be discussing about AAA. And then we have Ishikawa diagram, which is an outcome of Kaoru Ishikawa in the year 1960. Ishikawa diagram is also called as fishbone diagram. It is also called as cause and effect diagram. We have Dr. Edward de Bono, who has come up with 6 thinking hats. And then you have Pew matrix, which is output of the work done by Stuart Pew. And then we have Delphi technique, which is an output of these 2 gentlemen from Rand Corporation in the year 1960. So these are few scientists who have contributed to few of the tools and techniques which have ultimately found its roots in Six Sigma now. History of Six Sigma. Okay, let us discuss this in detail because this is the premise. History of Six Sigma. It started in Motorola by Bill Smith and Michael Harry, and it has saved them $16 billion in the span of 10 years. Amazing. Bob Smith, who is also called as father of Six Sigma, he has coined the word Six Sigma. Michael Harry in 1970. He has actually started statistical analysis for problem solving. He was a senior staff member at Motorola Government Electronics Group. That was what it was called at that point of time. He experimented with problem solving through these statistical techniques. Using this approach, Motorola's products were being designed and produced at a faster rate and at a lower cost. And he was a person who has coined the words black belt, green belt, and this kind of karate, kung fu, right? Belts, basically. Under the leadership of Bob Galvin, who was the chairman of Motorola in 1987, Six Sigma was started as a methodology in Motorola. That was the good part, right? And the ultimate result was this company has saved $16 billion in 10 years. And soon, companies have followed. Companies have started adopting Six Sigma. Allied Signal, General Electric, obviously, right? It's extremely well known for implementing Six Sigma at its fullest. Honeywell, Philips, Sony, Seagate, Toshiba, so on and so forth. They followed the route, right? And they have soon made Six Sigma the philosophy of their life. That is the interesting part. Now let us look into Introduction to Elementary Statistics. In this, we'll be learning about how to draw inferences based on the data which is provided to us. And of course, we'll be making use of statistical tool called as Minitab in actually accomplishing this, right? Statistics is broadly divided into 2 branches. One is descriptive, one is inferential. Descriptive statistics focuses on how to collect data, how to analyze the data, how to present and describe the data set which is provided to you. And what is inferential statistics? Inferential statistics is all about making decisions about a larger set of data, which is called as population. You make inferences about the population based on a small set of the data, which is called a sample. Think about Apple conducting a survey to collect what are the bad features of iPhone 6. Suppose this is what Apple wants to do. Can Apple go and approach each and every iPhone 6 user and collect the data on what are the features they do not like the most? It will be extremely cumbersome. It will take probably another 5 years to collect the data, right? It's extremely difficult. So what do? Instead of approaching all iPhone 6 users, you randomly pick a subset, a section of this population and start collecting the information on what are the features they do not like. Once you collect the data, you analyze the data and make statements which will be applicable to the entire population, basically. So using a small sample, you're going to make statements about the population. That is inferential statistics. All right. We will also explore the statistical tools and techniques that enable the decision making, which would include what are the data types, what are the measures of central tendency, what are the measures of dispersion, what is the probability distribution, and among that, there are a lot: beta distribution, gamma distribution, binomial, Poisson, so on and so forth. But we'll be primarily discussing about normal distribution in this section and its applications basically. And also we'll look into how to graphically represent the data so that it's extremely relevant for us rather than crunching huge set of numbers. There's a famous saying, right, that a picture speaks 1,000 words. Hence, we will look into few of the graphical representations such as box plot, etc. Let us look into the two main data types. The first data type is attribute data, which is also called as categorical data. What can be done using categorical data? You can count it, you can rank it in an order, or you can sort it in ascending or descending order. But you cannot perform any of the mathematical operations on it. You cannot add, you cannot subtract, you cannot divide, right? So these kind of operations would not be possible with categorical data or attribute data. Attribute data or categorical data. Here is an example. It's also called as discrete data or defect data, right? All right, that's fine. So discrete data. Number of cars. I can say that I have one car, or I have two cars, or three cars, or four or five cars. But can I say I have 1.5 cars? Or can I say I have 2.5 cars? Or can I say I have 3.6 cars? Does it make sense? It's not going to make any sense, right? You can have one car or two or three or four or five cars, but you cannot have zero point 0.5 cars in decimal format. So the moment I divide the number, it's not making sense for me. And that is a way to identify your attribute data or categorical data or discrete or defect data. Or it can also be something like this. I have so many red balls, so many blue balls. Gender, male or a female, though there are other genders, we'll not discuss about that. Or good or bad, right? So these kind of things are called as attribute or categorical data. On the other side of the spectrum, we have continuous data, which is also called as variable data, which can be measured on a scale and can be divided infinitely into parts. And it's still going to make sense. Few of the examples, wait. I can go to any accuracy level. I can say that I weigh 80 kgs, or I can say I weigh 80.5 kgs. Or I can say I weigh 160 pounds, or I can say I weigh 160.9 pounds, or I can say I weigh 170.68 pounds. I can go to any accuracy level possible, and it is still going to make sense for me. I can say I arrived office in 1 hour, or I can say I arrived office in 60 minutes. I can say I've arrived office in 3600 seconds. It's still going to make the same sense for me, right? How much ever you wish to divide continuous data, you can do so and it is still going to make sense, unlike your attribute and categorical data. All right, let us look into the preliminaries, basics of the statistics, right? If a data is given to me, what do I do first? I need to perform simple measures. What are those? Let's look into first measures of central tendency. We have discussed about population and sample, the notations used, and the formula used to calculate each one of these would differ a little. So please pay attention here. There are three measures of central tendency. One is mean, one is median, and the third one is mode. For a population, you represent it using mu. Mean of a population is represented using mu. It's summation of all the numbers divided by the number of numbers you have in the data set. Right? You see Greek letters primarily for population. If it's a sample, you represent mean or average as x bar, which is also summation of all the variables divided by the number of variables. It's denoted by small n because it's not the complete set, right? It's just a sample of the population. Mean is affected by the outliers basically. Hence, you can probably look into median. Median is middle value of the data. Let me explain this. Let us first look into mean or average. Right? If I have numbers 1, 2, 3, 4, and 5, if I take a simple average of this, how would I calculate? 1 plus 2 plus 3 plus 4 plus 5, which would be 15. I would divide that by the number of digits that I have. Sorry, the count of this. Right? I have 5 numbers here. So I divide it by 5, which is 3. The mean is 3 in this case. Take another data set. Say I have numbers 1, 2, 3, 4, and then 50. What would the count be? What would the summation of these numbers be? It'll be 60. And since there are 5, 1, 2, 3, 4, 5 numbers, I divide it by 5. And the mean is 12. And the mean here is 3. The difference is only one number, 50 here, which is pulling up your average extremely high, right? This is called as an outlier basically. The number which is extremely low in comparison to the rest of the numbers, or a number which is extremely high in comparison to the rest of the numbers. If you have such outliers, mean would not be a feasible option. What do? You look into either median or mode. What is median? It is the middle value of the data. Say I have numbers 1, 2, 3, 4, 5. Median in this data set would be 3 because that is the middle number. Or you can simply calculate using a formula also. If I have n numbers, in this case I have 5 numbers. So I do 5 plus 1 divided by 2, which is 6 by 2, which is 3. The third number is the median, and this is the third number. Formula is n plus 1 by 2 basically. N is the number of numbers that I have in the data set. It is fine in this case, median, right? Extremely easy. What if I have an even data set? Yeah, now what do? It's simple. Take the average of the middle numbers because there is no middle number here. So I take average of these two, that is 3 plus 4 divided by 2, which is nothing but 7 by 2, which is 3.5. So the median in this case would be 3.5. Let me ask you, what is the median of this? 10, 7, 6, 9, 2, 1. And let me put 3 also. What would the median of this data set be? Would it be 9? Will you be right, correct in saying so? Answer is no. You will have to arrange these numbers in ascending or descending order. Let me arrange 1, 2, 3, then 6, 7, 9, and 10. Now it's arranged in ascending order. The moment you arrange these numbers in the ascending order, the middle number would become the median. This is how you calculate median, right? Mode. Mode is the most occurring value in the data set. If I have 1, 1, 2, 3, 4, 5, which is the number which is appearing maximum number of times in this data set? It is 1. It's appearing twice, and no number is appearing twice here. Hence, that is called as mode. If I have only one mode, it is called as unimodal. It is called as unimodal dataset. I can have bimodal as well. 1, 1, 2, 2, 3, 4, 5. 1 is repeated twice, 2 is also repeated twice. No other number is repeated more than once. Hence I have two modes, 1 and 2. This is called as bimodal. This is called as bimodal or modal, however you want to call it. I can also have multimodal dataset if there are n number of numbers which are repeating n number of times. All right, that is all about mode. Let us look into one more example. 3, 4, 5. In this scenario, the number which is repeated maximum number of times is 1. It's repeated thrice. So hence I have one mode which is called, which is 1 in this case. So it is called as unimodal. All right. Let us look into the various measures of dispersion now. We have three measures of dispersion: variance, standard deviation, and range. Variance is calculated using sigma square, and formula is summation of x, which is each number minus the mean, square it and divide it by number of data set points. If it is a sample, the formula would change and the notations would change. It is s square. It is nothing but summation of x minus x bar whole square. You see small x is here because it's a sample, and here you see n minus 1 instead of n. There's a slight difference that you'll have to notice. If I take a square root of variance, I would get standard deviation. Nothing else changes. But variance and standard deviations are impacted by outliers, similar to the impact which we have seen in mean or standard deviation. And in such cases, you go with a range. A range is nothing but maximum minus minimum value. If I have 1, 2, 3, 4, and 5, range would be 5 minus 1, which is 4. All right. Okay, here is a quick exercise for you to actually identify the mean, median, mode, variance, standard deviation, and range for these numbers. Yeah, you can either make use of Excel or Minitab, or you can do a manual calculation. It's left up to you. All right, try it for your own understanding while I move forward. All right, here comes the case study. The good part is we'll be moving away from the theory and doing a little practical now. Here is a case study. We have two internet service providers, and both of these have similar average call resolution time. The time taken to resolve the calls is the same on an average, right? Against a promised resolution time of 30 minutes. 30 minutes is what I promised the customers. I'll tell them, or I told them that I would take a maximum of 30 minutes to resolve their issues over call. Now, when you have taken the average, you have seen that both of these internet service providers on an average have the same resolution time. Would you be correct in saying that they are equally good? Yes or no? The answer is no. You should not just stop at mean. Mean is a central tendency as discussed in the previous slides. Not just that, you also have to look into the measures of dispersion, variation. To comment on which one is better, would you like to consider variation as a resolution time as well? Yes. If yes, how would you measure the variation? Would you be looking into the range of standard deviation? Which one do you think makes sense for you? Can we find a single measure for process performance that incorporates central tendency, variation, specification limits, everything in a single shot? Can we do that? Answer is yes. Boxplot is an example for that. All right, here is a case study. Two internet service providers A and B answer approximately 1,000 technical calls in a month. We recorded the call transaction time of 100 randomly selected sample calls per ISP. Customer wants issues to be resolved in 30 minutes. Now tell me which service provider is doing a good job. Is it A or B? In order to know this, let us open the Minitab file and start working a little on the Minitab. And even before, okay, since I've discarded, let us move on. Here is the data in minutes of internet service provider A and internet service provider B. Right, the time taken in resolving the customer queries that is provided here. All I need to do is go to Stat, Basic Statistics, and then I want to display Descriptive Statistics. I click on that, and here is the pop-up window. I need to select Internet Service Provider 1, press the Shift key, select on Internet Service Provider B. Click on this button, Select. Both of these variables are selected now. Go to Statistics and see what are the various things that you want to generate. I want mean, I want standard deviation, I want to see the variance, I want to see what is the minimum value, maximum value. I want to see how many samples I have, what is the count of the data set. I want to see the first quartile, third, and the median. Now I click on OK. Once I click on OK, let me click on OK once again here. And here is the descriptive statistics. Yep. Let us go back to the window. Let us look into that and understand. So you need not worry about the navigation, etc. It's provided in the screenshots here. So it's extremely easy to navigate. Here is the count of the output. We have picked up 100, both for internet service provider A and B for sample analysis. Right? Out of 1,000 calls, which I take in a month, 100 is a sample that I've picked. Look at the mean of A and B. It's approximately the same. So do you conclude that A and B are both doing a good job? No, we do not do so early. We will look into standard deviation as well. Oh my God, if I see the standard deviation, internet service provider B is not doing a great job. There's a huge variation in the time taken to resolve the calls. Minimum time that internet service provider B takes is 5, and minimum time which internet service provider A takes in resolving is 11 minutes. And then you have Q1, median, Q3, and the maximum value. We will discuss about these things in box plot. Range is maximum minus minimum value. If I look into the range, it's 16 and 24 here. So once again, internet service provider has a lower range in resolving the incidents or calls. Interquartile range is another thing which we are going to discuss in the box plot. So hold on to your horses until then. Yep. Let us look into graphical summary also. So let me go back to the Minitab file once. Do not worry about the navigation. As I've told you, navigation path is provided right in the screenshots. So do not worry about that. Understand the concepts first. Okay, in order to go back to the worksheet, I need to click on this show worksheet folder. I'm back in the worksheet now. All you need to do is go to Stat, Basic Statistics, click on Graphical Summary. Select Internet Service Provider 1, press the Shift key, select the other one, and click on the Select option. Click on OK, and the magic box does the rest of things for you. Internet Service Provider A and B, we have the dataset now. Okay, I have these two lined up one beside another. Okay. Look at the mean, standard deviation, variance, students kurtosis. We not discussing this out of scope. How many points are there? 1,000 data points. 1,000 data points. Oh, sorry, 100 data points here. Mean, standard deviation, variance. Right? Either do this and try to look into that. By the way, this is called as box plot, which we are going to discuss now. This is called as box plot. We have an outlier here. We'll discuss about those things in just a minute, but just to give you a brief about how the graphical summary looks. This is called as histogram. We'll understand that. These bars are called as histogram. This graph that you see is called as probability distribution curve. Probability distribution function that provides this curve. All right. So we will deep dive as in how we progress, right? We'll try to understand Darling normality tests, p-values and all that, confidence intervals and all that. But not now. This is just the introduction. So let me go back to the presentation. All right. Now let us try to understand what a histogram is. This is a histogram that you're seeing here. But how to plot that? What does that mean? Flip a coin 20 times. Why 20 times? Why not 100 times, right? So let me ask you this question. If I'm going to flip a coin once, what is the probability that I'll get a head or a tail? You would obviously say it is 50%, 0.5. If I toss a coin twice, what is the probability that I'll get a head? Will you still go with 0.5? So are you 100% sure that if I'm going to flip coin twice, I'm going to get head once, and the next time I'm 100% going to get the tail? Can you say that with 100% confidence? No, right? If I am flipping two coins, I might get 0 heads, or I might get head once, or I might get head twice. What if I flip a coin 3 times? I might get 0 heads, 1 head, 2 or 3 heads. So the probability changes, and there might be multiple values that it might take. So if I flip a coin 20 times, all right, record the number of heads that I'm getting each time. If I repeat steps 1 and 2 for 500 times to represent 500 people, and then graph the results, a number of times I have flipped, and what is the probability of getting ahead? If I plotted, this is how it would look like. And if I do this experiment a million times, billion times, trillion times, then this would look symmetrical. That is called as concept of central limit theorem. I'll not discuss about that in detail now. Let us look into another graphical technique which is called as box plot. I can represent 100% of my data in a graphical format which is called as box plot. Do not worry, we are going to do this box plot in Minitab as well using the same internet service provider case study. So just try to understand how a box plot looks like, what are the various options in that. The lowest position in a box plot is called as minimum value. And these lines which are extending here and here are called as whiskers. This line is called as lower quartile or Q1. The data from here until here would be 25%. The middle box is called as interquartile range. It contains approximately 50% of the data points. That box contains 50%. This is called as median, which we have already discussed. This is called as upper quartile or Q3. From here until here, you will get 75% of the data points. And this is called as a maximum value. Q3 until maximum, you would have 25% of data. So 25% plus 75 would turn out to be 100%. So 100% of the data can be represented diagrammatically using something called as box plot. And if you have these kind of dots or star mark somewhere outside the box plot, those are called as outliers. Yep. Okay. So this is how you navigate the mini tab to arrive at the box plot. Let me try to do this for you guys. Okay. How do I go back to the worksheet? I just click on the symbol, show worksheets folder. I go back to the worksheet now. How do I navigate and go to the box plot? Simple. Go to graph and box plot. I have two Ys or two entries here, internet service provider A and B. So I'll select 2 and click on OK. Then I select internet service provider A, press the shift key, select internet service provider B and click on select. Job done. A simple OK. Magic. Right, here is a box plot. This is box plot for internet service provider A, this is for B, and this is the outlier star. This is the minimum point. This is called as Q1. From here until here, you will have 25% of the data. This box is called as interquartile range, which contains 50% of the data. This line is median. This top is called as Q3. From here until this whisker end, there will be 75% of the data points. And this highest point is called as maximum point. Same goes with internet service provider A as well. This is the star. Let us see whether we can select that item. Yep, that's the option. I want you to carefully observe this. When I highlight the star, it shows me that row 90 is a culprit here. Let us go back to the dataset and see what this row 90 of internet service provider B means. I click on this to go back and see what row 90 means. Here it's given row 90, which is the outlier if I select this. Clicking on this. Row 90 of internet service provider B. Internet service provider B is in this column. Let me see 90. Oh, here it is. There's a point. Right? Small square rhombus here. Right? 5. So someone has taken 5 minutes in order to resolve a customer issue. And none of the other points show that. Most of the other points are in 20s, 90, 19 minutes, 18 minutes, 11 minutes, so on and so forth. That's an exceptional point. Hence, it is showing as an outlier. All right. Let me go back to the presentation and let us look into the other stuff. Okay. Normal distribution is extremely beautiful. Like the curve shows you, right? It's approximately symmetrical. So you can represent a normal distribution which is characterized by the mean mu and standard deviation this. Look at this. Mu is equal to 0, standard deviation is equal to 1. If you give those two, this blue graph represents this. Mu is equal to 0, standard deviation is equal to 0.5. It's represented using this graph. Now look at the difference. If mean remains the same, sorry, and if the standard deviation reduces, your normal curve becomes thin and the height increases. Let us see what happens if the mean remains the same and the standard deviation increases. If the mean remains the same and the standard deviation increases, then It's represented using this green graph, this one, dark green graph, right? Height reduces in comparison to the blue, and also it becomes wider, right? So if the mean is same and standard deviation increases or decreases, what is going to happen is explained here. All right, now let us see what would happen if the standard deviation remains the same, that is the variation remains the same, but the mu changes from 0 to -1. It's represented using this orange line here. Right? So there is a shift. If it is minus, this particular graph is moving towards left. If the mean is positive, it's moving towards the right. It's represented using the graph. So this is a small explanation. So you can characterize each and every normal distribution curve using two values, which is mu, mean, population mean, and standard deviation, which is population standard deviation. It is characterized by the bell curve. If you see, the curve looks like a bell, right? And it has following properties. 68.26% of values lie within ±1 standard deviation from the mean. If this is the mean, if this is +1 and -1, the number of data points which satisfy the customer requirements would be 68.26. If it's operating at plus or minus, if a process operates at ±2 sigma standard deviation, then approximately 95.44% of the data points meet the customer requirements or meet the specification limits. If you look into ±3 sigma, it's 99.73. ±3 sigma, most people say, or they have this wrong way of interpreting this. They say I have one standard deviation, 2 and 3 on one side, and then on the other side also I have 3 standard deviations. All these 3 sum up to 6 standard deviations, and that is 6 sigma. No, my dear friends, you'll go wrong in this interpretation if you interpret in this way. 6 sigma means there has to be 6 standard deviations which fit in from the mean to one side of the specification limit. I have 6 standard deviations, and this is a formula. 99.999998% of the requirements of the data points or of the products meet the specification limits. That is how you will have to interpret this. Or it can be on the other side also. If there are 6 standard deviations from mean to the other side of the specification limit, it is called as following 6 sigma process. Yep. Think about the same example. Upper specification limit of ICC cricket ball is 229 mm and lower specification limit of ICC cricket ball is 224 mm. Yeah, this is what you would get. All right, let us move on. We know the histogram concept. We know if I plot, it's going to follow some distribution, which is called as probability distribution plot. Let me switch back to Minitab and explain this concept as well. All right. Don't worry about the navigation, it's provided there. You just need to go to graph probability distribution plot. Okay, I'm on this worksheet. I need to go to plot probability distribution plot. I want to view the probability, and I want to do this for both of the service providers, internet service provider A and internet service provider B. But I need to know the mean and standard deviation for both internet service provider A and B. Already we have done that exercise. Let me go here. This small icon here is going to tell you what are the various things that you have done in this session. Okay, it brings me back to the first exercise which we have performed in doing descriptive statistics. So now let me go to graph, probability distribution plot. I want to view probability and check what is the probability that internet service provider A might exceed 30 minutes in resolving my calls, because 30 minutes is the customer expectation. Any issue with the internet, I call the customer care, they have to resolve it within 30 minutes. That's my goal. And now I want to check what is the probability that internet service provider A would exceed 30 minutes in resolving my issues based on the historical data. I also want to check what is the probability that internet service provider B would exceed 30 minutes in resolving my issue. So let me click on OK. We know that it was following normal distribution. Now you might ask me, how do you know that it was following normal distribution? We cancel this. Let me go to the graphical summary. Now comes a small concept called as Anderson-Darling normality test. In this, if the p-value is greater than 0.05, 0.352, it's greater than 0.05. If it is greater than 0.05, it follows normal distribution. It's also visible when you look at the graph. For now, just understand that. Right? We will do a deep dive in this as in how we move forward, as in how we progress in the program. Let me see whether internet service provider B is also following a normal distribution. If I look into the curve, it seems like it's following normal distribution, but let me look into AD test, Anderson-Darling normality test, p-value at 0.157. Is it greater than 0.05? Yes, it is greater than 0.05. Hence, you conclude that both data of internet service provider A and B is following normal distribution. Now let me click on descriptive statistics. Let me go to graph, probability distribution plot, view probability and click on OK. So we know that it's following normal distribution. There are other distributions also available. But for us, we know that it's following normal distribution. What is the mean of internet service provider A? It's given here. Mean for internet service provider A is 19.480. 19.480. And what is the standard deviation for internet service provider A? Standard deviation is 3.689. 3.689. If I click on OK, look at this. It says that there is a 0.05% probability that internet service provider A would exceed 30 minutes. Yeah, I purposefully have done this. Look at this, 25.55. For those of you who are sleeping, wake up. For those of you who were awake, you caught this, right? So if I want to go back to the previous screen on which I was working, I need to click on this option, edit last dialog box. I come back here. I go to the shader region. I want to find out the probability that service provider A exceeds 30 minutes. Now click on OK. Now it says that there is a probability of 0.002174% that internet service provider A exceeds 30 minutes in resolving your issues. That's for internet service provider A. Look at this, 0.002174. It's very minuscule. Now let me go back to the descriptive statistics which we have done. Now I'll go back to graph, probability distribution plot, view probability, click on OK. Now I'll do the same exercise for internet service provider B. What is the mean here? Mean is 19.46. What is the standard deviation for internet service provider B? 5.518. 5.518. I do not click on OK yet. Don't repeat the mistake. Go to shaded region. Click on X value. I want to check the probability that probability of internet service provider B exceeding 30 minutes in resolving my issues. I click on OK. It says internet service provider B has a probability of 0.02806% of exceeding 30 minutes in resolving your issues. This clearly says internet service provider A has done a good job. A. And this is for B. Yep. All right. Friends, let us go back to the presentation. Do not worry about the navigation. It's clearly mentioned over there. Look at this. What is Six Sigma performance? We already discussed this. If a Six Sigma process, if you feel that a process should operate at Six Sigma, that means you should be able to fit in six standard deviations from the mean. My bad. Let me redraw that. I'm bad at drawing, by the way. From here till here, you need to fit in six standard deviations. And if you can fit in six standard deviations, then you can claim that you're operating at Six Sigma process. Think about boxing competitions, right? Floyd Mayweather, he has never lost even a single match. What makes him so strong? And if you say that I want to go and have a match against Floyd Mayweather, no one is going to entertain you. Why? Because they're going to test on you. If I deliver the punches as powerful as Floyd Mayweather on you, how much time can you sustain? Right? How many standard deviations, how many punches a process, a boxer can take and still meet the specification limits or still stay in the ring without getting knocked out. That is called as standard deviation and Six Sigma process, right? So you need to just fit in six standard deviations. Assume that the variation is high in the process. If the variation is high, the standard deviation would be more. Suppose this is my specification limit. Specification limits, by the way, my dear friends, it will not change. Customer has told me that upper specification limit should be 229 mm. Lower specification limit for an ICC cricket ball circumference should be 224 mm. Those will not move. If your standard deviation is not so much, say it is so much, then you can fit in only two standard deviations. And if you can fit in only two standard deviations from the mean to the specification limit, your process is called as following 2 sigma, not 6 sigma. Only and only if you can reduce the width of the standard deviation, you can fit in 6 standard deviations in that. Now let me ask you one question even before we move on. At what sigma level does airlines industry operate at, or a pharmaceutical industry? Do they operate at 6 sigma? 6 sigma means 3.4 defects per million opportunities. Say there are a million flights which are taking off or landing, right? By the way, in a week, there would be a million flights which would take off and land. Including domestic, international, warfare, helicopters, all that, right? A million would touch within a week. Within a week, are you hearing that there are 3 crashes or 4 crashes? No. They do not operate at 6 sigma level. Airlines, your nuclear missile, space launching, healthcare, they operate at a sigma level which is much higher than 6 sigma. Few claim it is 8 sigma, few claim it's 9, few claim 12. But To be honest, it is much higher than Six Sigma. All right. Now you know the difference between standard deviation and sigma level. Sigma level is represented using Z value, standard deviation using this Greek letter. One more thing which I want to tell even before we move on. All the population representation such as mu is mean for population. Sigma square is a variance of population. Sigma is a standard deviation of population. All these are Greek letters. Population of sample is represented using X bar, variance of sample using S square, and standard deviation of sample using S. So that is how you differentiate. Also, we know that the formulae change for variance and standard deviation when it comes to population versus sample. We also know that the notations change for mu and sample in the formula used to calculate. All right, this is a simple representation of a sigma level. If your process is operating at 2 sigma level, there would be so many defects per million. Pathetic. If you're operating at 4 sigma level, 6,210 defects is what you would see in your process. If you're operating at 6 sigma level, then you would see that there are 3.4 defects per million opportunities, right? Moving from 2 sigma to 3 sigma, 3 to 4, 4 to 5, 5 to 6 is a Herculean task. To be on the safe side, if you're doing a consulting engagement for a client and if they're operating at 3 sigma, do not promise that you would take their process from 3 to 6 sigma by implementing a 6 sigma project. Not possible at all. All you can do is you can move maybe from 3 to 4 sigma, maybe from 4 to 4.5, 4.5 to 5, and then try to move to 6. The higher sigma that you want to attain, more difficult it would become for you to implement the process. Yep. By the way, ST stands for short term. We will discuss about short term and long term when we discuss the measure phase. Until then, hold on to your horses. Okay, if you're operating at 3.8 sigma level, you would see 99% good things. But if you're operating at 6 sigma level, you'll see 99.99966% good things. That's the difference. Though in percentage terms, you might feel that there's not a lot of difference. Look at the numbers. 6,210 defects to 3.4 defects. This is called as a breakthrough methodology. All right, now let us differentiate between this and this. We have already done that in the previous slide, but let us try to understand once again. As the variation or the standard deviation reduces the defects. Defects also reduce significantly. As in how the variation reduces and the defects reduce, your sigma level goes up, which is your 6 sigma. Or if you want to attain 6 sigma, your variation and the defects should reduce. Going back to the definition of 6 sigma, which we have discussed in the first few slides, right? 6 sigma is all about reducing variation and reducing the defects, right? Okay, there are few assumptions that specification limits or the customer requirements, goals do not change, and process average remains constant. Those are the two assumptions. This is by far the most important equation of 6 sigma, or I would say this is by far the most beautiful equation that I've seen. Any output y is dependent on few inputs, function of inputs. Y is, say, weight of a person is dependent on calories consumed. Salary drawn, which is output, is dependent on a number of certifications that I possess. years of experience that I possess, graduation degree that I possess, right? If I say that I'm Six Sigma Green Belt certified, probably I'll get some salary. If I say I'm Six Sigma Black Belt, obviously I would get a higher salary. If I say I'm Six Sigma Master Black Belt certified, obviously the salary would further increase. So any output is dependent on function of inputs. Mileage of a car is dependent on horsepower, cc of the vehicle, suspension of the vehicle, air pressure of the vehicle, number of people it can take, the variant, is it petrol vehicle or diesel vehicle, right? All those are going to define my mileage. So that is y is equal to f of x. To get results, we should focus on a behavior on y or x. That is the question. Now to answer that, let us answer this. Is it feasible to eliminate the inspection of y if x's are controlled well? If I take care of my inputs, will the output be taken care of? Absolutely yes. Try to improve your inputs. Your output is automatically taken care of. That's the law of nature, by the way. Here are the various names for your output variable. It's also called as dependent because it is dependent on your inputs. It's also called as output, effect, symptom, monitor, or response variable. It's going to respond to the inputs. X, which is your input, is also called as independent variable, cause, problem, control factor, so on and so forth. You need to understand these different terminologies because different mathematical or statistical or Six Sigma books use different terminology. So you need to be aware of all that. All right, a quick summary about whatever we have discussed until now is as follows. We discussed about Six Sigma history and how it evolved. We also discussed about basics of Six Sigma methodologies, DMAIC, DMAC, and also design for Six Sigma in the form of DMA-DV. We discussed about elementary statistics. We have discussed about measures of central tendency, measures of dispersion, right? We discussed about mean, median, mode. We discussed about variance, standard deviation, and range. We looked quickly at few of the options available on Minitab, and we worked on internet service provider case study. Yeah, we have also looked into histogram, what that means. We have also looked into box plot, the various options available in box plot. We looked into quartile 1, minimum value, interquartile range, quartile 3, and then the maximum value, and also the outliers in box plot. We discussed about probability distribution, and also normal distribution was something on which we have spent some additional time on. We also tried to look into the differences between what a sigma means and a sigma level means. Lower the sigma, higher is the sigma level. Lower is the sigma, lower is the defects, higher is the sigma level. And finally, we looked into one of the most beautiful important equations, that is, any output y is dependent on one input or multiple inputs. With this, I stop here and look into our subsequent sections in order to understand what happens in a define phase, what happens in a measure phase, analyze phase, improve phase, and control phase. All right, I'm extremely happy to have recorded this session for y'all. Hope you found this extremely useful. Thank you, and let us look into this program a little further. See you.